Hello students, in the previous video I have done up to number 4 of 4f, and today I am starting from number 5. Here first question is 2x square plus kx plus 3 equal to 0. And here question is find the values of k for which the following quadratic equation has real roots. If I compare this equation with ax square plus bx plus c equals to 0, in that case a will be 2, b will be k, and c equals to 3. Now as given in the question, we have to find the value of k for real roots, and we know for real roots d is greater than equals to 0. You can write here for real roots. d is b square minus 4ac, so b square minus 4ac greater than equals to 0. Here b is k, so it will be k square minus 4 into 2 into 3 greater than equals to 0. So k square minus 4 to the 8, 3 8 the 24 greater than equals to 0. Now since it is square, this 24 also can be written in terms of root over 24 whole square. So we can write k square minus root over 24 whole square greater than equals to 0. If we apply a square minus b square formula, it will be a plus b into a minus b greater than equals to 0. Now we are multiplying these two numbers. This is one number, this is another number, and we are going to get greater than equals to 0. So either both of them must be positive or both of them must be negative. Because if this is positive, this is negative, then the product will be negative, and that number cannot be greater than or equals to 0. So we can write either k plus root over 24 greater than equals to 0 and k minus root over 24 greater than equals to 0. From here I will get k greater than equals to minus root over 24, and from here k greater than equals to root over 24. Since k is greater than root over 24, so definitely it will be more than minus root over 24. So from these two we can write k greater than equals to root over 24. So k greater than equals to root over 24 can be written as 2 square. 2 square is 4. 4 into 6. So k greater than equals to 2 root over 6. Now if you consider this is also less than 0, this is also less than 0, we can write or k plus root over 24 less than equals to 0 and k minus root over 24 less than equals to 0. From here k will be less than equals to minus root over 24 and k will be less than equals to root over 24. Since k is less than equals to minus 24, so definitely it will be less than root over 24. So from these two we can write k less than equals to minus root over 24, which can be written as k less than equals to minus root over 2 square into 6. So k less than equals to minus 2 root over 6. So we got therefore either k is greater than equals to 2 root over 6 or k less than equals to minus 2 root over 6. Here you can just consider, suppose here it is 3 and here it is minus 3. If I say a number is less than minus 3, definitely that number will be less than 3. Similarly, out of these two, once we say k is less than equal to minus root over 24, so definitely it will be less than root over 24. So out of these two, we have considered this negative part. Okay, so finally we got k greater than equals to 2 root over 6 or k less than equal to minus 2 root over 6. Second part of question number 5. Question is kx square plus 6x plus 1 equals to 0. Here a equals to k, b equals to 6 and c equals to 1. For real roots, discriminant d is greater than equals to 0. So since d is b square minus 4ac, so b square minus 4ac greater than equals to 0. Here b is 6. 6 square minus 4 into k into 1 greater than equals to 0. So 6 6 is 36 minus 4k greater than equals to 0. So minus 4k greater than equals to minus 36. Since both sides are negative, if we multiply both sides by minus, then sign of inequality will change. So 4k will be less than equals to 36. Just think 3 and 2. Out of 3 and 2, 3 is greater. But if I take minus 3 and minus 2, then minus 2 will be greater. Similarly here minus 4k is greater than equals to minus 36. So 4k will be less than equal to 36. So k less than equal to 36 divided by 4. So k less than equals to 9. Therefore k less than equal to 9 is the required answer. Third part of question number 5, you can do it yourself. Let me show fourth part from question number 5. Here question is 2x square plus kx minus 4 equals to 0. If you compare this equation with ax square plus bx plus c equal to 0, then a will be equals to 2, b will be equals to k, and c will be equals to minus 4. For real roots, d is greater than equals to 0 for real roots. Now d is b square minus 4ac, b square minus 4ac greater than equals to 0. Here b is k, so k square minus 4 into 2 into minus 4 greater than equals to 0. So k square minus minus plus 4 4 the 16, 16 to the 32 greater than equals to 0. For any real value of k square will be 0 or more than 0. So we can write for any real value of k, k square will be greater than equals to 0. So k square plus 32 will be greater than to 0. Therefore, k belongs to any real number. So k will be any real number, so which can be written as k belongs to set of real numbers. In question number 6, it is given, find the least positive value of k for which the equation x square plus kx plus 4 equal to 0 has real roots. Now in this case, a equals to 1, b equals to k, and c equals to 4. For real roots, d is greater than equals to 0. So it will be b square minus 4ac, 4ac greater than equals to 0. We can write directly also, or if you want, you can write b square minus 4ac greater than equals to 0. Here b is k, so k square minus 4 into 1 into 4 greater than equals to 0. So k square minus 4 4 the 16 greater than equals to 0, which can be written as k square minus 4 square greater than equals to 0, which can be written as k plus 4 into k minus 4 greater than equals to 0. So either here we are multiplying these two numbers and we are going to get 0 or more than 0. So either both of them will be positive or both of them will be negative, which can be written as k plus 4 greater than equals to 0 and k minus 4 greater than equals to 0. From here we got k greater than equals to minus 4, k greater than equals to 4. Since from these two we got k greater than 4, so definitely it will be more than minus 4. Therefore, from these two we can write k greater than equals to 4. Or we can write k plus 4 less than equals to 0 and k minus 4 less than equals to 0. From these two we will get k less than equals to minus 4, k less than equals to 4. From these two again we can write k less than equals to minus 4. In the question it is given, we have to find the least positive value of k. So we are not considering negative part, we have to consider this. Again here it is given least positive value. Here least positive value is 4 because here it is given 4 or more than 4. Therefore least positive value of k is 4. Therefore k equal to 4 is the required answer. In question number 7 it is given, find the value of k for which the following quadratic equation has real and distinct roots. First question is x square minus kx plus 9 equals to 0. Here a equals to 1, b equals to minus k, and c equals to 9. In this question it is given, we have to find the value of k for real and distinct roots, and we know for real and distinct roots condition is d greater than 0. Now d is b square minus 4ac greater than 0. b square, that means minus k whole square minus 4 into 1 into 9 greater than 0. Minus minus plus k square, 4 9 is 36 greater than 0. So k square minus 6 square greater than 0. Now if we apply a square minus b square formula, it will be a plus b into a minus b greater than 0. since this is one number, this is another number, and their product is greater than 0, so either both of them must be positive or both of them must be negative. It is not possible that one number is positive, another number is negative. So in the first case, we are considering this is also positive, this is also positive. So we are writing either k plus 6 greater than 0 or k minus 6 greater than 0. From here, k greater than minus 6, k greater than 6. Since k is greater than 6, so definitely it will be more than minus 6. From these two we can write, therefore k greater than 6. Again, both of them can be negative. In that case, we have to write or k plus 6 less than 0 and k minus 6 less than 0. From here, k less than minus 6, k less than 6. Since k is less than minus 6, definitely it will be less than 6. From these two, I can write k less than minus 6. Therefore, required value of k is either it is greater than 6 or it is less than minus 6. Therefore, k is greater than 6 or k is less than minus 6 is the required answer. Question number 8. Find the least value of k when 4 minus kx square plus twice k plus 4x plus 8k plus 1 is a perfect square. Suppose this is equals to 0. If discriminant part is 0, then this will be a perfect square. So here a equals to 4 minus k, b equals to twice k plus 4, and c equals to 8k plus 1. Since we have to find the value of k for this expression to be a perfect square, we can write d equals to 0, because if d is 0, then only this will be a perfect square, which is b square minus 4ac equals to 0. Now b here is twice k plus 4 whole square minus 4a into c. This is equals to 0. Here a plus b whole square, if we apply, it will be twice k whole square plus twice ab plus b square minus 4 into 4, we can write 16 minus 4k, 4 into 4 16, 4 into k 4k into 8k plus 1 equals to 0. Now 2 to the 4, it will be 4k square plus 4 to the 8, 8 to the 16k plus 4 4 the 16 minus, now we can multiply 16 with 8k plus 1 minus 4k into 8k plus 1. This will be inside the bracket equals to 0. So it will be 4k square plus 16k plus 16 minus 16 into 8, it will be 128k plus 16 minus 4 is the 32k square plus minus minus 4k equals to 0. So 4k square plus 16k plus 16 minus 128 minus 4k, it will be 124. So minus 124k plus minus minus 16 minus minus plus 32k square equals to 0. Now 32k square plus 4k square, it will be 36k square. 16k and here it is 124k. 16 and 124, from these two I am going to get 108k plus 16 minus 16 cancels equals to 0. From here 36k can be taken common, to k minus 3 equals to 0. So either 36k equal to 0 or k minus 3 equals to 0. From here k will be 0 and from here k equals to 3. So we got k equal to 0 and 3. In the question it is given find the least value of k. Out of these two, least value is 0. Therefore, least value of k equals to 0. And that's the required answer. And this is the last sum from this exercise. In the next video, I'm going to start from 4G. Till then, bye bye, take care and wait for the next part.